So we're going to start off with the basic concepts of matter chapter, and it starts by focusing on the definition of chemistry. What you should always do while you're watching these videos and while you're reading the book is print out the what you need to know list. So for you guys, it's chapter 1, what you need to know list. Starts off with the definition of chemistry, and chemistry is basically the study of the characteristics, composition, transformation of matter. Okay? Characteristics, what do we mean? We're talking about, well, is it a solid? Is it a gas? Is it a liquid? What are the characteristics? So we'll be getting into that. So maybe a solid, liquid, gas, or maybe we talk about the density or the color. Those are the characteristics of matter. Okay. Composition, we're talking about, well, what's it made out of? Is it made out of, is it an element? Is it a compound? Is it a bunch of elements and compounds mixed up together? Is it a mixture? So when we're talking about the composition of chemistry, we're usually focusing on pure substances versus mixtures, and we'll get into that. Okay, you'll see those terms in your what you need to know list. And then I know this is not very clear, but hopefully you can zoom in and see all this. Transformations, those are the reactions. Physical changes, chemical changes. How is matter transformed? Will iron react with oxygen to become rust? What about gold? Will gold transform if it reacts with oxygen? Does it react with oxygen or doesn't it? So transformations are basically the changes that occur in matter, whether they are physical changes or chemical changes. Okay, so this is, as a chemist, these are the things you're going to be studying this semester. Okay, what in the world is matter? Matter is pretty much everything. I'm matter, this pen is matter, this whiteboard is matter, the coffee I was drinking, there's still some left here, that's matter. Anything basically that takes up space, so has some type of a volume and has mass. Has mass. Okay? Well, then what's mass? What's mass? Most people think of mass and weight as the same thing, but weight is affected by gravity. So you know how they say the astronauts are weightless? So when you go up, in the atmosphere, when you go to the moon or whatever, you're weightless. But so weight is affected by gravity, but mass is not. Mass is how much matter is packed into something, all right? So when we're in lab and we're talking about weighing something, really what we're doing is we're saying, what is the mass of something? But you're going to see that in this class, we interchange the two. If I ever tell you what is its weight, what I really should be saying is what is its mass, okay? But if we mix them both up, it's totally fine. All right, so now you know the definition of chemistry. Let's focus now on the next thing on our what you need to know list, which is know the 3 physical states of matter. What are the 3 physical states of matter? Solids, liquids, and gases. So solids, liquids, and gases. Let's talk about some properties that solids, liquids, and gases have. A solid is going to have a definite shape, and definite volume. For example, if you look at this eraser over here, you can see it has a definite shape. It's a solid. Does it have a definite volume? Yes. If you want to measure the volume of this cuboid, you would take the length times the width times the height, and that would be the volume. So solids have a definite shape, definite volume. Well, what about liquids? Liquids have a definite volume. They definitely have a definite volume. So for example, this bottle over here of Kroger purified water has a volume of 500 milliliters. Okay, 500 milliliters. Let's go metric in this class. Forget the 16 fluid ounce English. So 500 milliliters. So we know that if I fill this bottle with water, it's going to have a definite volume. I have 500 milliliters. If I open it up and I pour it in my coffee cup, it'll still be 500 milliliters. So it has a definite volume. But shape-wise, right now, if this was filled with water, the shape would be like the shape of the bottle. But if I pour it on the floor here in my kitchen, obviously the shape is different. So for a liquid, it has an indefinite shape. Okay? What about gases? And we have a whole chapter later on in the semester that deal with all the different properties of gases. They're quite fascinating. But gases have an indefinite volume and an indefinite shape. Okay, so both the volume and the shape is considered indefinite with gases. The interesting thing about gases is that the gas particles can be squished together, compressed like crazy, and then they can expand. So for example, if I had a green gas in here, a toxic green gas in here, I would say that the volume of the gas is 500 milliliters. But then if I open it up and allow all the gas particles to move around, you know what? They're going to fill my whole house. And now the volume is the whole volume of the house. Do I have more gas particles? No, it's just that now the space between the gas particles is bigger. So gases have an indefinite volume, meaning actually they take the volume of whatever container they're in. So if you put it in here, the volume would be 500 milliliters. If you allow it to go through the whole house, then the volume would be the volume of the house. And obviously an indefinite shape, because now the shape was this and now the shape would be the whole house. So it depends on what container it's in. Okay. All right, so those are some properties of solids, liquids, and gases. Just a quick note here. How do you turn a solid into liquid? All you do is have to heat it up. So we're adding heat. What is that term called when you go from a solid to a liquid? That's called melting. Liquid to a gas, you add more heat. That is boiling, all right? So the point where the solid gets turned into a liquid, that is the melting point. The point where the liquid gets turned into a gas, that would be the boiling point, okay? What about the reverse? You can turn a gas back into a liquid. What are you going to have to do? Take away heat, so subtract heat. And that means you're condensing the gas. And then going from a liquid to a solid, also you're taking away heat, and this would be freezing, okay? Just real quick, and I know this board is looking super messy right now. Since we're talking about this, you can go directly from a solid to a gas and bypass the liquid state entirely, and we're going to be doing a lab that deals with this. Solid all the way to a gas, that is called sublimation. You're going to see that mothballs, if you have mothballs, they're a solid, and then give them enough temperature, enough heat, they don't melt. They just sublimate and become a gas directly. And then a gas can become a solid without becoming a liquid, and then just going directly from a gas to a solid. That is called deposition. And while I have all of this stuff, I think in your book they mentioned this a little bit, so I'm just going to mention it right now. Solids have a lot of cohesive forces, and very little disruptive forces. This is in case you see this when you're doing your homework, you know the terminology. The term cohesive forces means that solid particles like to stick together. Disruptive forces means the ones they stay away, far away from each other. So a solid has a lot of cohesive forces, very little disruptive forces. Gases are the exact opposite. They have very little cohesive forces and a lot of disruptive forces. Okay, and then liquids are somewhere in the middle. Okay, so that's our first introduction to matter. And when we come back in the next video, we'll talk about properties of matter, physical properties, chemical properties, and then we'll talk about physical changes and chemical changes. This beginning chapter deals just with a whole bunch of like definitions, concepts, just to give you a preview of all the good things we're going to be doing later on in the semester. Okay? All right.